Alright, so the beginning of section 1.1 is done. I'm going to try and keep these videos kind of short because, let's be honest here, attention spans don't last that long. So I'm going to try and break it up and give you guys a chance to pause, go look at the homework, go watch a YouTube video, I don't know, maybe another math video. And then come back and keep going with stuff here. So this is continuation of section 1.1. We just got done with building the real numbers. Now we're going to look at ways to organize them. To me, a good way of organizing is something that will, a rule that will split it into two groups and that everything will fit into either one group or the other. One of the most common ways of splitting them is to think about even and odd. I don't think I need to explain that. You guys already know even and odd. But that kind of gets you thinking about it. Okay? So this is one way of organizing the numbers. Another way is even more basic, is to think about positive and negative. A lot of times students will come up with that if I give them a second to think about it. This one's not quite as good because there's this question of where does 0 go? And that's a great question, one I can't answer. We really haven't given it a label whether it's positive or negative. It just is. 0 is just a concept. But still, it makes a fairly decent division between two groups because there's only one number that's left out as an oddball. Another good split on these is to put them into prime and composite. Composite just being the opposite of prime. That's why I say splits into two groups pretty nicely, because that's either a prime number or it's not. Prime numbers being 1, well, technically not 1. I'm going to count it in this class, but not technically. 2, 3, 5, 7, 11, 13, 17, 19, and you can keep the list going from there. Composites would be everything that I skipped then. All the other stuff fits into it. And most textbooks don't talk about it, but I would also say that the negatives should go in with the composites, because definition of prime is that the only multiples are 1 and the number itself. That's literally what prime means. So a composite number, if you think of -7, you could have 1 times -7, or you could have -1 times 7. And either one gets you the same number in the end. It has multiple factors. So that's why I would say it goes into the composites. Probably won't read that in a book anywhere, but it's an idea that I think should be there. Same kind of idea goes for even and odds. The negative sign doesn't really make a difference, so people don't talk about the negative numbers as going into either even or odd, but you can do that too. Okay? If you have another way of splitting them up, another rule that you know about, feel free to send it to me. These are kind of the basic ones I came up with whenever I was thinking about it. So whenever you're doing the homework, those are the basic ideas. Other concepts that we've got to use here in this class, we have symbols, symbology. So 4 different symbols I just put up there on the board. Hopefully you guys recognize all of them. We have the less than or equal to, greater than or equal to signs. If I need to explain that, again, send me an email. I will. Otherwise, I'll assume that it's pretty self-explanatory. These are put together with the real numbers to make what's called the real number line. Without the idea of less than or greater than, we have no reason to put one number before another. But once you define that, and once you understand what's bigger and what's smaller, you can write out a list like this. And we're going to come back to this real number line pretty often throughout class to explain some different concepts. Okay? Make sure that you also remember that on the real number line, you can list any real number. So if I was just writing this up here and I wanted to look at 1/2, I know that that point right there is where I would find 1/2, even if the number's not listed. I know I can place it on the real number line. Okay? This lets us get into variables. So the first time in this class that we're seeing variables, basically it's anything that takes the place of a number. So a variable represents some unknown value. Some unknown value. Terrible E. Sorry, bad handwriting, still trying to work on that for you guys. People try and make too much about variables. I know that it's always find the x in algebra, that's always the problem. It's just a number. That's literally all it is. That's all you're trying to do is find the number that can go into that spot. Starting basic here, one of the first things that you need to get used to in math is translating. You go out and ask normal people, they won't tell you this, but math is really another language. Legitimately is another language. So whenever you're learning to deal with it, you have to get used to all these ideas that are interchangeable, or you could say them one way or another way and it all works out the same. Okay, so the first example I've got for you here is given these words, which I'm hoping you can read because I'd like to not say them. You should be able to read that sentence, and right away in your mind, you should start visualizing, or just automatically, numbers should start to come to the front of your head. You should just start seeing a list of numbers that fits this requirement. That's the start of translating in math. So think about it, write out a list. Try and give me some other way of phrasing this without the actual English words, some other way of putting it down. And so whenever you're doing this, you'll realize that writing out a list of numbers is not great, because there are too many. There are way more numbers than you will ever be able to write that are greater than 2. So, one of my personal favorites for explaining this is to go visually. I'm a big visual learner, so we're going to go to the real number line. It's really easy to express numbers that are greater than 2 on this. You know that you start at the number 2, and greater than goes that direction, and just like that, that line there tells me you understand what value you start at, what value you go to. Okay? So that's one perfect answer. Another way of doing this that we'll probably use, or you'll probably see more often because it's more algebra related, is using a variable like x. And remember, this just stands for numbers. So I can read this as numbers that are greater than 2. And both of these, or actually all three things you see on the board here, describe the exact same thing. And so as far as a language goes, they mean the same thing in math. And the hard part for you is going to be getting used to going from the words to the variables, from the variables to the visual, back and forth like that. So that's something for you to practice. Okay? Here's another one, and I'm going to give you a second here to work on this. If I was to write this variable form on the board and ask you to translate it, think about how you would do that. And I'm looking for 2 different ways. Take it back to the English, because that's the usual way that you have of trying to get your brain to start thinking about it, is to go to English, and then try and give me a visual picture. All right, so take a second, pause the video right here, try and do that, and see what you can get to. Then, I'm hoping, I'd like to not write this down because my handwriting's terrible, but for English, it should be something like the numbers that are less than or equal to -3, or the numbers that are greater than -1. Some English phrase like that is what I'm hoping you got to. Or visually, put out the real number line, and you guys are going to notice here that I don't have to put down all the numbers on the real number line, just the ones that I'm actually concerned about or I'm talking about. So, less than or equal to goes that way for -3. And here we come to kind of a small problem. If I'm going to do this like that, I realize there's an issue. Something I actually need to go back and fix. I can't use a circle for both of these numbers because I need some way of expressing less than and equal to, and then something that's not equal to. So here's the first change that I'm going to have to make to my work. Instead of having a filled-in circle whenever we're talking about just strictly greater than or strictly less than, I'm going to use an open circle. Which means that what we did previously, it wasn't wrong then, but now that I realize I've made a mistake, I have to go back and fix this. So this thing can stay almost exactly the same, except now I know that whenever it says greater than, without the equal to sign, I need to have an open circle to represent that. Make sense? If not, send me an email. Okay, there's one more idea in section 1.1. This one's going to go really quickly. We're going to talk about absolute values. Absolute values are those vertical bars that you see put around numbers. So this would be the absolute value of 3. And what it means is the distance that number is from 0. So whenever you put vertical bars around something, or the absolute value of a number, you're asking yourself how far that thing is from 0. Go back to the real number line if you want to, and actually count over the places. You realize that this thing is 3 away. Which is why, colloquially, we just say that the absolute values make things positive, because the distance is always positive. So if I'm looking at the absolute value of -5, just because it's in the negative direction doesn't change how far it is from 0. It's still 5 places away, which is why we say the answer is 5. And the only way this gets more complicated is if you have the absolute value of some number, then plus or minus something else. In this case, we haven't quite gotten to PEMDAS, which is order of operations, but it should make sense that you have to put these guys together first before you can worry about the absolute values, so that's where we begin. Think of -3 plus 2. Not too bad, right? And then you can do the absolute value to figure out what the final answer is. Okay? There we go. That finishes off section 1.1 totally. Ready for section 1.2 next time.